Okay, our goal for this particular section is kind of different from what we've done up till now. It's almost like we're going back to the beginning when we talked about linear equations. We're going to be doing some graphing. This chapter of all the chapters is going to be your real foundation prep for calculus next semester. So you need to pay careful attention, take good notes on this part. We're going to learn to find the domain and range of a function. We're going to learn how to determine if a relation is a function. We're going to determine whether an equation represents a function, evaluate that function for different values. We're going to graph functions by plotting points and learn about the vertical line test to identify functions, and then obtain information about the function from its graph, and identify the domain and range from the graph, and identify the intercepts from the graph. All very important concepts in calculus. We will use the graphing calculator a great deal in this section because I will expect you, when I get you in calculus next semester, I'll expect you to know how to use your calculator to graph and find intersection points and X and Y intercept points and things like that, and to build a table of values. So this is a very, very important chapter. Okay, a relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain of the function. The set of all the second components is called the range of the function or relation. If a component of either the domain or range repeats, it isn't necessary to list it twice. So here's an example. This one is not on your notes. Just pay attention with me, and then we'll do a couple of examples for you to figure out. Find the domain and range of this relation. The domain is the first component of every ordered pair. So it is 0, 10, 20, 30, and 40. The first component for each one. Those little curly brackets around that simply identify that as a set of ordered pairs for this particular relation. That's all we know about it. We don't have its rule, we don't have its graph, we don't have its equation. The range are all of what you think of as the Y values. It's the second component in every ordered pair. So the range is 9.1, 6.7, 10.7, 13.2, 21.2. So now you work with me. What is the domain of the set of ordered pairs 2, 5, negative 1, 3, and 4, 10? What is the domain and what is the range? Write down what you think on your notes. I need to minimize this for just a second so that I can get the document camera operating again. Okay, there we go. So for the domain of the first function, anyone want to volunteer what they think the three domain values are?
2, -1, 4.
That's right. The domain is always the first value. A lot of times it'll be listed in a table. So we'll do that too. And then the range is the second set of components. So that would be 5, 3, 10. So what you have in front of you is three ways right now that you can represent a relation. And we don't know at this point if it's a function yet or not because we haven't defined a function. What's the domain of the one in B?
1, 0, 3.
Okay. 1, 0. 1's in there again, and then we've got 3. So the 1 is repeated. We're going to leave it out because it's only listed once in the domain. So 1, 0, and 3. So even though it's in there twice, I'm going to put it in the table twice, but actually it doesn't get repeated in the domain. The range, on the other hand, is 11, 5, 6, 7. Okay? Now, here's the definition of a function. A relation in which each member of the domain corresponds to exactly one member of the range is called a function. A function is a relation, and this is just saying it a different way. A function is a relation in which no two ordered pairs have the same first component with a different second component. A function can have two different first components with the same second component. Okay? If you think of it in terms of x and y, an x can only have one y partner. However, more than one x can have the same y partner. Okay? So looking back here at the table that we just finished a second ago, this x goes with this y. None of the domain is repeated, so they all have independent partners. So this relation is a function. But here we have two instances where a value from the domain shows up, and yet it has different partners. You can kind of think of it as the value of one as being bigamist. The x has two y's. That's not allowed. Okay? So this is not a function. And it's not a function because each member of the domain did not correspond to exactly one member of the range. I'm sorry, circle the wrong one. So 1 corresponds to 11 and it corresponds to 6. So that's why it is not a function. Okay? is this relation a function? What do you think? Well, my domain values are 1, 3, 6, and 8. Since none of the domain values repeated, then that relation actually does define a function. Now, if 3 had shown up again, if there had been another ordered pair and it was 3, 9, then it's not a function, because that means 3 would have a different partner. But if 3 showed up again and its partner was still 4, then that still is a function. So let's determine whether or not each of these is a function. We have the points 2, 10, and negative 3, 0, and 4, 10, and 3, 7. Is it or is it not a function? What do you think? Okay, you think it is a function. Is it okay that I've got that? Is this okay? That 10 is partnered up with 2 different x's. The answer is yes. The domain has to have one and only one range, but the range can be partnered up with more than one area in the domain. So this is a function. Now moving on to the next one, we have 2, 10, 2, 0, 4, 10, and 3, 7. Is that a function? No. Which 2 points are a problem? The 2 has 2 different partners. For that reason, it is not a function. Here's where the problem is. Okay? Now, if I were to give you a quiz, next time we meet, you need to be able to explain to me whether something is or isn't a function. Next thing we're going to do is talk about figuring out if an equation is a function. Function is usually written in terms of an equation instead of ordered pairs. You can see why you get pretty tired of writing out ordered pairs. It takes a lot of time to write them out. But the rule for the function, which is the equation, is easy to write out. For example, if we have the linear function, 0.45x minus 17 is equal to y, X is what we call the independent variable because it can be assigned any value from the domain. And we're going to call Y the dependent variable because Y depends on what we substitute in for X. Okay? Another word for independent and dependent variables are input, because it's what you put in the function, and output, which is because after you put in your X value, the output is whatever happens according to the rule of the function. So if an equation is solved for Y, and more than one value of Y can be obtained for a given X, then the equation doesn't define Y as a function of X. And we're going to look at some equations where that doesn't happen. So for example here, determine whether the equation satisfies the definition or that it defines Y as a function of X. We've got X squared plus Y squared is equal to 1. So we try to isolate the Y squared first by subtracting X squared from both sides. And then we take the square root of both sides, and the square root of Y is, or well, Y squared, I'm sorry, is Y. And the square root of 1 minus X squared can be either positive or negative. Okay? Because you know that negative 4 times negative 4 gives you 16, as well as positive 4 times positive 4 gives you 16. So if somebody asks you to find the square root of 16, it has two answers, one positive and one negative. So the plus or minus shows that for certain values of X, there's going to be two values of Y. And for that reason, that equation doesn't define Y as a function of X. So we're going to determine whether or not each one of these is a function. And these are in your notes. So first we'll look at X plus 2Y is equal to 7. And we're going to solve it for Y. So Y is equal to 7 minus X divided by 2. Let's suppose I put in 5 for X. 7 minus 5 is 2, and 2 over 2 is 1. Is there any way to get a different answer if I put in 5 for X? Would I always come up with 1? If I put in 7, 7 minus 7 is 0 over 2, which is still 0. If I put in 7 every time, does the value of Y change when I do the arithmetic? No. So this is a function. It is a function. And the reason that it's a function is because each X corresponds to exactly 1 Y. And you can use the word unique, because that means there's one and only one. Okay? And we'll look at part B. X squared plus Y equals 16. Minus X squared minus X squared. Y is equal to 16 minus X squared. If I put in any specific number for X, is there any chance that there's going to be two different answers for Y? Let's say I put in 2. 16 minus 2 squared is 16 minus 4 is 12. If I put in 2 again, am I still going to get 12? Yeah. If I put in 9, 16 minus 81. Well, there's only one answer to 16 minus 81. You can't get anything else but the one difference. So for the same reason that this was a function, this is also a function. And it's for exactly the same reason. Each x corresponds to exactly one unique y. Then we'll look at the last one. And we have y squared plus x squared equals 8. And y squared would then be square rooted to get rid of the square. So it's going to be plus or minus whatever the quantity 8 minus x squared is. So for example, if I put in 2 for x, it's 8 minus 2 squared, which is 8 minus 4. How many ways can you get a number that it would give you 4 for the square? The square root of 4 is positive 2, because 2 times 2 is 4. But it also could be negative 2. Negative 2 times negative 2 is also 4. Okay? So y could be positive 2 or y could be negative 2, either one. And that means that it violates this rule. Because for any value of x, there are 2 possible values of y. That's why it's not a function. And that means for every value of x, not just any one value, but for every single value of x, you have 2 different y values.
Can you go back and zoom out?
We good to go? Okay. Now, this notation, if you've had algebra before, you've probably seen this, but if you haven't had it in a while, you may have forgotten some things. The special notation, f parentheses x, does not mean f times x. It's read as f of x or f at x. It represents the value of the function, any number x. Basically, it's telling you f has a rule. The rule is usually an equation, but it could be words. And it tells you what to do with x to get the value of f. So when you evaluate a function, if you had the function f of x is equal to x squared minus 2x plus 7, and you needed to evaluate f of negative 5, then you would plug in, everywhere you see x, you plug in negative 5. So f of negative 5 would be negative 5 squared minus 2 times negative 5 plus 7. And that would give us 25 plus 10 plus 7, which is 42. So f of, or f at, -5 is 42. Now I'm going to caution you about something, because this is a mistake I see all the time, and I don't want to see you make this mistake. When you try to evaluate that function on your calculator, here's my equation. I've seen people do this time and again. -5 squared minus 2 times -5 plus 7. And that's not the same answer. And it's not because that's not a function, because that is a function. What's wrong with the way I entered that in the calculator?
5 needs parentheses.
That's right, the 5 needs the parentheses. Because the only thing that that squared actually belongs to right now is the 5. It doesn't belong to the negative sign. So you square 5 and then leave the negative sign sitting there. What we should have done is this. And if you write it that way, you'll get the correct answer. Okay? So be sure and put your negative signs in parentheses. Unless you have a TI-84 calculator, be sure and put your fractions in parentheses. And if the fraction has a negative sign, put it in the parentheses with the fraction. Okay? Keep your quantities grouped up with your parentheses. Kind of corral them in. So now we're going to evaluate 3 functions by plugging in. Okay, this is our function. F of x is equal to x squared minus 10x minus 3. F of 4 is equal to 4 squared minus 10 times 4 minus 3. F of 4 is equal to 4 squared is 16 minus 10 times 4 is 40 minus 3. And 16 minus 40 is 24, negative 24. Negative 24 minus 3 should be negative 27. And if you've got a calculator, there's no reason to not check your math. And we got negative 27, so we know our answer is right. Then we'll move on to the next one. F of x plus 2. Whatever x is in the function, replace it with x plus 2 everywhere. And since the function was f of x squared, f of x plus 2 is going to be x plus 2 squared minus 10 minus 3. And then you want to simplify that. X plus 2 squared is x squared plus 4x plus 4 minus 10 minus 3.
It's 10x.
Oh, 10x. Thank you. So that should be 10x plus 2. 10 times x plus 2. So instead of that, I should have minus 10x and minus 20. So f of x plus 2 is x squared, and 4x minus 10x is minus 6x, and 4 minus 3 is 1, and 1 minus 20 is negative 19. So if it's f of some expression, and this is actually something we call a composite function, where you take a function, x plus 2 is itself also a function, if you put it as an equation. So if you do a composite function, basically you're putting in place of your independent variable or your input, you're putting in an expression rather than just a single variable. And when you do that, you just simply follow through and do all the math and simplify. The third one is f of negative x, which means exactly the same thing. Once again, we have x squared minus 10x minus 3, and we're going to substitute in negative x. So f of negative x is going to be negative x squared, and yes, you have to have parentheses, minus 10x, minus 10 times negative x minus 3. So when we simplify, what's negative x times negative x? X squared. And negative times negative is positive 10x, and then minus 3, of course, doesn't change. Okay? Questions on that? Now, you can use technology to evaluate functions as long as what you're putting in the function is a number, as long as it's numerical. For example, we were doing the problem a minute ago for f of x equals x squared minus 10 minus 3, and we need to find f of 4. Here's one way. There's going to be 2 or 3 ways you can do it. I'm going to show you a couple of ways, and they're very, very similar. The first way is to go to your y equals and put in the rule for the function, which was x squared minus 10x minus 3. Okay, so we've entered the function at the y equals. Then we're going to hit second and mode to quit, and we're going to press the vars key. That's where your variables are. We're going to go over to the y variables and choose function and go to y1, because we just put that equation in y1. And then you enter the value that you want to evaluate in parentheses. So in our case, we were wanting to evaluate that function at 4. So it took the rule, the equation that we put in at y1, it took the x value that we told it in parentheses, and it plugged that number into the equation in y1, and it did all the math for us, and it went very quickly, much faster than if we had to actually type all those in ourselves. Okay? So that's one way. There is a second way, and sometimes if you're needing to evaluate a bunch of different values, this second way might be the better one. You still begin the same way. You put your function in at y1. So we have x squared minus 10x minus 3. And then we set up the table, and we're going to do this in a kind of a strange manner. We're going to set it up to let us ask for specific x values, and it'll automatically tell us what the y value is. So if you set your table that way, and then go to table, if I ask it, what if I plug 4 into that equation at y1? And it says, okay, that'd be negative 27. So then I say, well, what if it had been negative 4? It says, well, it would have been 53. What if it had been 0? It would have been negative 3. So I can ask it for as many values as I want to. What I can't do is I can't put in there, what is f of x plus 2? It doesn't like that. It only does arithmetic. It doesn't do algebra for you. Okay? So we're going to use technology to evaluate this function. And this is not on your notes, so use your calculator to kind of keep up with this one. Our function is 4x plus 5. So go to y1 and put in your function 4x plus 5. Using the first method, we would go bars, y bars, function, y1, and then in parentheses we would put 6. And it says the answer is 29. And then if we need negative 2, we would again go bars, over to y bars, choose function, and y1, and in the parentheses we would put this negative 2. And it says the answer is negative 3. Or we could have gone over to the table and said, what is f of 6? It's 29. What is f of negative 2? It's negative 3. And any other number that we wanted to put in there, we could. If it had asked us for 20 different numbers, we could have gotten them all just by entering them in the X column. Okay? The table method is a little bit faster, but both the methods begin the same way. Now we're going to talk a little bit about what the graphs of functions look like. The graph of a function is the graph of its ordered pairs. But nobody likes having to plot a dozen ordered pairs. So we'll use the calculator for a lot of those. So, for example, if we graph the functions f of x equals 2x and g of x equals 2x minus 3 on the same graph grid, the same coordinate system, and we're going to select integers for x starting with negative 2 and ending with 2. This is what would happen. We put in x to be negative 2, negative 1, 0, 1, 2 for both x's. And then we would get our y values, and for f of x equals 2x, our y values are negative 2, negative 4, negative 1, negative 2, 0, 0, 1, 2, and 2, 4. And for g of x, our values are negative 2, negative 7, negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, 1. And then you just connect those with a straight line. You could also have used your calculator here. You simply go to your y equals menu, put in your first function, 2x, put in your second function, 2x minus 3, and you could build your ordered pairs by going second graph and enter in the x values. Negative 2, negative 1, 0, 1, 2. And notice that I built both tables at one time by doing it that way. So the calculator will be a handy little helper if you learn how to use it efficiently. Okay? So you can build your tables of values. You could also on your calculator, the best way to find a graph, since we're only going from -2 to 2, we'll just set the window up to go from -3 to 3, and use Zoom Fit because I think I've taught you how to do that before. So there goes the first equation, and there goes the second one. Okay? So here's -3, -2, -1, 0, 1, 2, 3. And the graph looks a little different, but not much, because the scaling on the window is different. Okay? So, as the slide says, use your calculator to check the tables and the graphs of these two. Well, the only thing we have to do is go back to y equals. And our first one is still 2x, but our second one is 2x plus 4. So there's your tables. And if you wanted to check your graph, you can also check your graph by just hitting graph, since we've got the same domain. And that's what your graph would look like. Okay? So we're going to pick up at the bottom of this page, finish the rest of this handout next time, and go on to do the next section. Be sure you get your skills check quiz done before I see you next time, that you start working on the first section of homework, please. Y'all have a good day.